Right, so we now deal with, continue from yesterday. We stopped at 4.1.3. This is still dealing with the April 2020 paper, 4.1.4. So we need to integrate cos 3x times cos of pi x. Okay, so in this case, the angles, we are multiplying cos times cos, the angles are different. So you will go to page 1 of the formula sheets. And page 1 has your trigonometry. Okay. So what do we know? You go to your formula sheet for this. Under trigonometry. And what are you looking for? You are looking for cos A times cos B. So you'll find this in the trigonometry, cos A times cos B, which is equal to half. And then you have cos of A plus B plus cos of A minus B. Right, so you use this when you are integrating cos times cos, or cos times sine, or sine times sine, or sine times cos. And the angles are different. Okay, so you've got angle, this is A, that's B, they are completely different. We apply the formula. So in this case, my A here is 3 pi x and B is pi x. So this is now equal to the integral of, so I'm applying the formula, so that will be half, there's my half here, opening brackets, this will be cos A plus B, so that's going to be 3 pi x plus pi x there, you can see that, A plus B, and then you got plus cos A minus B, so that's 3 pi x minus pi x dx. Right, simple. This is the easiest one from all the problems. All you do is you add up A and B there. So we got cos of 3 pi x plus pi x will be 4 pi x. 3 pi x minus 1 pi x is 2 pi x. And then it's ready, each term is ready to integrate. Okay, so here, when you're integrating something of this nature, where it's just cos of bx, when you integrate cos, that's going to be positive sine bx all over b plus c. Okay, so this is equal to 1 over 2 integrate cos, that will be sine 4 pi x all divided by the coefficient of x, which is 4 pi. Integrate cos 2 pi x, that's going to be sine 2 pi x all over 2 pi plus c. You can leave your answer like this, it's fine. So this is fine. Or if you want to remove the brackets, it's going to be 1 over 8 pi times sine 4 pi x, and that will be 1 over 4 pi times sine 2 pi x plus c. You're done. Very simple. Remember, angles different. You go straight to page 1 of the formula sheets. So that was 4.1.4. Is there anything left under this question? Oh yes, 4.1.5, the next one. So 4.1.5. This is x times the square root of 1 plus 2x. Okay, now this type of example, if you look at it normally, we have an exact derivative. So if this is like x squared, then you have an x because it's an exact derivative, type A. But the problem is there is no exact derivative. Okay, the derivative of 1 plus 2x is not x. Okay, so what do we do? So these are your special case examples. You have to use a substitution here. And you have to get everything in terms of a very different variable. So let's use our u substitution. So here what we can do is we can let u equal to 1 plus 2x. So if you let u equal to 1 plus 2x, then du over dx, the derivative of 1 is 0. Derivative of 2x is 2. So then dx is going to equal to du over 2. So let's look at what happens when we do a substitution as this. So I got my integral, I got the square root there. 1 plus 2x is no more 1 plus 2x now. It is now replaced with the letter u. And dx is going to be du over 2. The problem is the x. We are now transforming this whole problem from the variable x to now the variable u. We are now integrating with respect to u. So therefore, the variable x cannot be here. So what do? We need to get x also in terms of u. So what do? We go back. Remember, u was equal to 1 plus 2x. So, u minus 1 is equal to 2x. Can you see that? So, therefore, u minus 1 over 2 is equal to x. And now, we have x in terms of u. That's all. So, x is going to equal to u minus 1 all divided by 2. So I'm replacing x with u minus 1 over 2. Can you see that? Now, simplify. So 1 over 2, that will give me 1 over 4. You got u minus 1 multiplied by u to the power half du. Now it's a simple n4 type problem. We need to remove the brackets, use our exponent law, and then integrate. So u to the power half times u. When we are multiplying and the bases are the same, you will write down the base once and you add the exponents. 1 plus half is 1 and a half, which is 3 over 2, and then minus 1 times u to the power half is u to the power half du. And now we integrate with respect to u. So that will be u to the power 3 over 2 plus 1. So 3 over 2 plus 2 over 2 is 5 over 2 divided by 5 over 2 minus u half plus 1. 1 over 2 plus 2 over 2 is 3 over 2 divided by 3 over 2. Plus C. You're done now. All you have to do is substitute back. The main job is done. So therefore this is equal to 1 over 4, and that becomes 2 over 5, and that becomes the square root of u to the power 5 minus 2 over 3, and we have the square root of u cubed plus c. So if I remove these brackets, this is going to be 2 over 1 over 2, so that's going to be 1 over 10. The square root of u to the power 5, and that will be minus 1 over 6 the square root of u to the power 3 plus c, and what was u? U was 1 plus 2x. Right, so that was question 4, integration. Right, so let's move straight to question 6. Same paper, this is April 2020. So question 6 deals with differential equations. So in N5, we deal with first order, separating the variables, and second order by direct integration. And then we continue with this in N6 with linear differential equations and also second order linear differential. Right, so here the main thing is you must be able to manipulate this equation. So this is a differential equation. Basically, it's an equation that has been differentiated. There's variables x and y in the same equation. So what we want to do is we will have to separate the variables. Okay. So let's write this down. So what do we have here? dy over dx is equal to x times e to the power x squared plus 2 all divided by 6y squared. So what we need to do here is separate the variables. So what do I mean? Get dy and all the variable, all the y variable terms on one side, and get your dx and all the x terms on the other side. So what can we do? I got a fraction on the left, fraction on the right. I can cross multiply. Okay, so if I cross multiply, so that will be dy multiplied by 6y squared is equal to x times e to the power x squared plus 2x times dx. You see that? Now, once your variables have been separated, now we can integrate both sides. Okay, so now you're going to integrate both sides. The left hand side, you're integrating it with respect to y, that's dy. The right hand side, you're integrating with respect to x, there's your dx. Okay, so here on the left hand side, we got 6y squared. On the right hand side, okay, we have two terms. Right, so what I can do here is I can separate this into two different problems. Why? Because if you look at term 1 compared to term 2, they are completely different types. Okay, the way you integrate term 1 is completely different from term 2. This is multiplication and this deals with exact derivatives. How do I know that? Because the derivative of x squared will be 2x. You are interested in the x. Okay. So let's write it as x e to the power x squared. Separate them into 2 plus the integral again with respect to x, and this is just 2x. Okay. So here for this one, I have done an example like this using substitution. Okay, you go to the previous question 4. So this one, let me do it by inspection. Okay, so by inspection, the derivative of x squared. Okay, when I say by inspection, let me just refresh your memory. This is what I'm going to do. I got k e to the power f of x multiplied by the exact derivative of the exponent f prime x, And if this is the situation, then the answer is going to be k e to the power f of x plus c. So, the derivative of e to the power, the derivative of x squared, so is 2x. Okay, we're using inspection. The derivative of x squared is 2x. But there was no 2 originally, so I'll multiply by 1 over 2. Can you see that? So half and 2 give you the original 1. So now it satisfies the condition. So this is equal to just e to the power, sorry. This is equal to k there, which is half e to the power x squared. Right, that's inspection. This, if integrate 2x, that will be 2x squared over 2. Left hand side, 6y to the power 3 over 3. And you only put down plus c on one side. Don't put down plus c on both sides. It's unnecessary. Just put it on one side of the equation. So, we're done. It's just a simplification now. 6 divided by 3 is, so that's 2y cubed is equal to half times e to the power x squared plus x squared plus c. Alright, so now at this stage, this is called the general solution. Okay, it's a general solution. We still have plus c there. Okay. Now this question stated find the particular solution. So we have values. We want to know what's happening at this point. When x is equal to 0, y is equal to 1. So you must understand that y of 0 equal to 1 means that when x is equal to 0, y is equal to 1. Alright, so what we're going to do is simply go back, replace y with 1 and x with 0. So let's do the substitution now. So I'm going to go 2, so therefore I got 2y cubed is equal to 1 over 2 e to the power x squared plus x squared plus c. And wherever we see y, we're going to replace it with 1, which is only on the left hand side. Can you see that? Wherever you see x, you're replacing it with 0. So that's 0 there, 0 there. We can work this out. So 1 to the power 3 is 1, and 1 times 2 will be 2. Here, 0 squared is 0. E to the power 0 is 1. 1 times half will give me half. 0 squared is 0, so I just got plus c. Clear with that? So therefore, 2 minus half is equal to c. So c is equal to 1 and a half. Okay, 2 minus half is 1 and a half. So therefore, the particular solution, particular, or it can be called unique solution. So it's particular, or another word would be a unique solution. So you go back, copy down the general solution, which is 2y cubed is equal to half times e to the power x squared plus x squared. And what did we just find now? We found the value of c, which is 1 and a half. So that was 6.1. Let's deal with 6.2. Right, question 6.2. So this is a second order. Let me just see, oh sorry, first order again. Let me just double check that. My mistake is d squared y, dx squared. d squared y, and I forgot to write down squared. So this is a second order differential equation where you can separate the variable again. Okay. Now, if you notice that there is no y's here, there's only x's. Compared to the previous one where you had the variable y, so you had to manipulate. So in this case, we can do this by direct integration. Okay, so what we can do is we get d squared y over dx squared alone on the left hand side. So what do? I can divide. So I don't want this x squared, so I'll divide by x squared, and you divide every single term on both sides by x squared. So now I end up with 1 times d squared y over dx squared is equal to x to the power 6 divided by x squared. When you are dividing and the bases are the same, you write down the base once, top exponent, subtract bottom exponent. So therefore this will be x, 6 minus 2 is 4 plus x again, 3 minus 2 is 1 minus 2, 2 minus 2 is 0, anything to the power 0 is 1, or basically cancel. Right. Now, we have the second derivative. That means this is a result of an equation that has been differentiated twice. So if we want to find the solution, the general solution, we have to integrate 2 times. Okay, direct integration. So if I want dy over dx, so this now, at the moment it's the second derivative, so from the second to the first derivative. If I want to go from here to here, I need to integrate what I have. Okay, so I need to integrate x to the power 4 plus x to the power 1 minus 2. So when I integrate this will be x to the power 5 over 5 plus x to the power 2 over 2 minus 2x plus c. This is still dy over dx. Okay, now this is still the first derivative. We want to get to the original, so that means we need to integrate one more time. So I want y. So if I want to work out y, that means I need to integrate whatever I have here one more time with respect to x. So this is going to be, I need to integrate 1 over 5, x to the power 5, 1 over 2, x squared minus 2x, and I also need to integrate the constant. So when I integrate this is going to be x to the power 5 plus 1 is 6 over 6 times 5, which is 30 plus x 2 plus 1 is 3 over 3 times 2, which is 6, and here minus 2, x 1 plus 1 is 2 all over 2 plus integrate c, it's going to be cx, and whenever we integrate we put a constant, so let's call our constant d, or if we want to we can call it this c1 and call that c2, it's just a constant. Right, so this is y general solution. Because we don't know the values of c and d. Okay, so just a general solution. Now, this question stated, find the particular solution. So, these values, x is equal to 1, y is equal to 1 over 5. When x is equal to 1, dy over dx is equal to 5. So we got two different equations, two substitutions. Right, so what do we know? Let's start with this one here. So here we know that dy over dx is equal to 3 over 5. So let's substitute it. So I got 3 over 5 is equal to dy over dx is equal to 3 over 5 when x is equal to 1. So I'm going to replace 1 there. So that's going to be 1 to the power 5 over 5 plus 1 squared 2 minus 2 times 1 plus c. Okay, so what do we get now? We work it out. So this is going to be 3 over 5 minus 1 over 5 minus 1 over 2 plus 2 is equal to c. So 3 over 3 minus 1 will be 2 over 5 plus 2 minus 1 over 2. Right, so you can just work this out on a calculator, stretch. Okay, you don't have to go and show working, but if you want to, then you can find an LCD. The LCD will be 10, so 2 times 2 will be 4, so that will become 4 minus 5 plus 20 all divided by 10 is equal to c. So 4 minus 5 is minus 1. So 20 minus 1 is 19 all over 10 is equal to c. Is that correct? Right, so 19 over 10 is equal to. In the exam, you don't have to do this the long way. Okay, all you do is you just substitute. Okay, now let's work out the second part there. So what did I do here? I used this equation. The first derivative, to find c. Now, I still need to find d. So, remember that when x is equal to 1, y is equal to 1 over 5. Right, so we're going to substitute into this equation when y is equal to 1 over 5. So now I'm going here. Right, so I'm going to the general solution. What do we know? When y is equal to 1 over 5, so I got 1 over 5 on the left hand side, and x, the value of x is constant, it does not change. Okay, so x is equal to 1 for everything. So that will be 1 to the power 6 over 30 plus 1 to the power 3 over 6 minus 1 squared and then plus cx, so that will be plus 19 over 10 times 1 plus d. That's just plus d. Okay, so now what we're going to do is simple now. Just take your calculator, let's work out the value there. Give me the calculator. Right, so what do we have here? We got 1 over 5 minus 1 over 30 minus 1 over 6 minus 1, but that's not minus 1, that will be plus 1. So that's plus 1 minus 19 over 10. And I get minus 9 over 10. Double check that. Right, minus 9 over 10. So therefore, particular solution Substitute. So y is equal to 1 over 30 x to the power 6 plus 1 over 6 x to the power 3 minus x squared plus 19 over 10 x, and then we got minus 9 over 10. Is that correct? Double check that answer. Let's have a look at question 1, dealing with limits. So 1.1.1, what do we have here? We have the limit as x approaches, or x tends to 1 over x. Then we have this fraction 9x minus 1 divided by 3 times the square root of x minus 1. So what do? We substitute. And let's see what happens. Substitution 1 over 9. So this is going to equal to 9 times 1 over 9 minus 1. And then we got 3 times the square root of 1 over 9 minus 1. Let's see what we get. So 9 and 9 will cancel. You end up with just 1 minus 1 at the top. The square root of 1 is 1. The square root of 9 is 3. So 3 and 3 will cancel. You end up with 1 minus 1 in the bottom. So that's a 0 over 0. Okay. So this is an indeterminate form. So what do? So if we have a limit in indeterminate form, we differentiate the numerator and the denominator separately. Okay. And then resubstitute. So this is equal to the limit as x approaches 1 over 9. Differentiate the numerator, that's going to be 9. Differentiate minus 1, which is 0. Differentiate 3 times the square root of x. So 3 times half is going to be 3 over 2. X, half minus 1 will be minus half. Differentiate minus 1, 0. So what happened here? We need to indicate that you differentiated. Remember, we are calling this f of x, call the denominator g of x. So when we differentiated, we found f prime x and we found g prime x. This is not the quotient rule. We're differentiating the top separately from the bottom. Okay, this is sounds I have lots of those. So this is the rule that we're using. So what do? We find the first derivative of the top, first derivative of the bottom. Then we simplify it, resubstitute. So let's simplify it first. So this is going to equal to the limit as x approaches 1 over 9. So I have 9 divided by 3 over 2 there. So this is what I have, 9 divided by 3 over 2, which is the same as 9 times 2 over 3. So 9 divided by 3 is 3 times 2, which will be 6. So that becomes 6. Take this to the top. The sign of the exponent changes. Can you see that? If I take square root x to the top, or x to the power minus half to the top, it becomes a positive half. So simplify first. Now do the substitution. So this is equal to 6 times the square root of 1 over 9, which is 6 times the square root of 1 divided by the square root of 9. And the square root of 1 is 1 and the square root of 9 is 3. So 6 divided by 3 will be 2. That's it. (1.1.2) we got the limit as x approaches 0, cosec minus cot. So step 1 is substitutes. But you need to know your identities, because on your calculator you do not have a cosec function button. We do not have the cot. So you need to use your identity, and let's see what we have here. Cosec. So basically, cosec x is 1 over sine, and cot can be written as 1 over tan, which is this also. It can be written as cos over sine. Okay, it's up to you. Now, so what do we have here? We have basically cosec minus cot, which is the same as 1 over sine minus cos over sine. Right, that's what we have. So now, if I substitute 1 over sine 0 minus cos 0 over sine 0, what do we get? So, this you do not do on your calculator in one step. You work out each one individually, because the calculator is going to give you an error. You need to know what type of error it is. The calculator doesn't know, you need to know that. So sine of 0 is 0. Then cos of 0 is 1. Sine of 0, 0 again. So 1 divided, a positive 1 divided by 0. When we're talking about limits, this is going to be infinity. Okay. Minus 1 over 0 again. Infinity. So that is, this is the symbol for infinity, minus infinity. Okay. Infinity is a very, very large number, okay, which we don't know the value of. So now, be careful. Infinity minus infinity is not the same as x minus x. It's not the same as y minus y. So it's definitely not 0. Because this infinity could be 900 billion. This infinity could be 700 billion. You cannot assume that they are equal. So therefore, this is indeterminate. Right, so you show that this is an indeterminate form. Right, so now what do you do? So here we're showing that. So you show you're working on the side here, you can see that. But you change cosec minus cot. Now, we need to differentiate. So this rule only applies to fractions. You must have one fraction. So where is the fraction? So what we do is the limits as x approaches 0. Now I've already done the working here. 1 over sine minus cos over sine. Can you see that? It has a common denominator of sine. Your LCD there is sine. So now you have 1 minus cos. So what are we doing? We are rewriting it in this form. Numerator we call f of x, denominator g of x. So always rewrite it as a fraction. And now we already know that this is an indeterminate form. So there's no need to go and show it again. Okay, we already showed you infinity minus infinity. If you do the 0 again, you're still going to get the same. Now you'll get 0 over 0. Still indeterminate. So what do you do? Differentiate the numerator, differentiate the denominator. So this will be equal to the limits as x approaches 0, differentiate 1, that's 0, differentiate minus cos, that's minus sine, The derivative of cos is minus sine. There's already a negative here. You can see that the derivative of sine is cos. So you must indicate the rule. What did you do there? So I found the first derivative of the numerator, because I identified the numerator as f of x, so the first derivative is f prime x. First derivative of the denominator, g prime x. And now, what do we do after differentiating? We simplify and then resubstitute. And if we resubstitute and we still get an indeterminate form, then we need to find the second derivative of the top. Second derivative. There's certain examples where you have to differentiate 3 times at the top, 3 times. This one is an easy one, this paper. Certainly compared to the others. So this is equal to the limit as x approaches 0. Negative times negative is a positive. Sine of the cos is tan x. So you must simplify after finding the derivative. We don't just go and resubstitute. Okay. So now you've got the limit as x approaches 0 of tan x, which is now equal to tan of 0, which is 0. So that is the answer for this one. So that was 4 marks. 4. Question 1.1.2, and it is not a difficult 4 marks. The next question here, 1.2, determine the values of x for which f of x is discontinuous. Okay. So now, where would this function be discontinuous? Now this is a fraction. Okay, so what do we know? When you have a fraction, you cannot divide by what number? If you divide by what number, will it be undefined? 0. So we cannot divide by 0. So the denominator must not equal to 0. So in order for this graph to be continuous, it will be continuous for every single value except the values that make this denominator equal to 0. Right. And that is the theory for this one. So for discontinuity, let's just write this down. So we know that f of x is discontinuous when x squared minus 2x, which is the denominator, when the denominator is equal to 0. Okay, that's the time it will be discontinuous. So when will the denominator equal to 0? We need to solve for x here. So x squared minus 2x is equal to 0. Simple, take out x as a common factor, so we are left with x minus 2 equals to 0. So therefore, x is equal to 0, or x minus 2 is equal to 0. So x is equal to 2. So if we substitute 0 into this denominator, it will result in 0. If you substitute 2 into the denominator, you also get a 0. You cannot divide by 0. So therefore, these are the values. There's your 2 marks. These are the values for x that will make this graph discontinuous. Okay. Now, let's move on to the next one. Derive a formula to determine dy over dx if y is equal to arc cot, that equals inverse. We're dealing with the inverse of cot. Okay. So how do we do that? This is only 2 marks. So how do we do that? So let's write this down. So what do we have here? We have y is equal to cot. If you don't want to write down AR, CR, you can always put down a minus 1. It means the same thing. Just a different way of writing it down. So y is equal to arc cot of x. Now, what we're going to do here is we're going to come out of the inverse function back to the original. What was the equation before you reach this point? So what we're going to do is we put cot on off both sides. So this inverse cot, so if I want to cancel the inverse cot, I'm going to put just cot. Okay, so I'm going, now I cannot do it on one side, I have to do to both sides. So basically this is cot of inverse cot x. Okay, so now cot of inverse cot x is just x. Those two functions basically cancel each other out, and you're left with what it was originally, x. So on the left hand side I have cot y. Now there's no more inverse, I just have cot y is equal to x. So now I can differentiate both sides. So if I go d over dx of both sides, so d over dx of the left hand side, d over dx of the right hand side. So this is the derivative of x, which is 1, and the derivative of cot y, but with respect to x now. So this is called implicit differentiation. Okay, so let me just write that down. This is implicit. So the derivative of cot y will be negative cos x squared y, and you multiply by dy over dx. Shortcut, implicit. Whenever you're differentiating y, differentiate it using the normal rules, but you multiply by dy over dx. Now we need to make dy over dx the subject of the formula. So dy over dx is going to equal to 1 divided by minus cos x squared y. Right, now here we got minus cos x squared y. We want our answer in terms of x. Okay, not y. So how do we get cos x squared y in terms of x? So go back to this part here. Cot y is equal to x. So this is it. Remember, cot y is equal to x. So what is the relationship that we can link here between cot y and cos x squared? We need to, what type of relationship can we link them? So what do you need to remember? When you see squares in trigonometry, square identities. So that is, for all these type of problems here, you must remember your square identity. So from your square identity, we know that 1 plus cot squared y is equal to cosec squared y. This is given to you if you forgot it. 1 plus cot squared is equal to cosec squared. So therefore, 1 plus cot squared is equal to cosec squared. Why am I introducing a bracket there? Because I know that cot of y is actually x. So therefore 1 plus x squared is equal to cosec squared. So therefore this is going to be 1 divided by minus, and then I got cosec squared. So it's better to write down the minus here. You understand that? Whether it's 1 divided by minus 1 is minus 1. I just want the cosec squared, because cosec squared is 1 plus x squared. And that is how you derive the formula for inverse cos. Easy, just your square identities are given to you if you forgot.